A new life in a delicate balance, grasping for survival. How do you take the measure of something so fragile or so distant as the rhythm of a pulsar, a universe away, or the speed of light? Mechanical measurements are adequate for a number of applications. But some things are just too big, or too small, or too fast. In the late 1800s, physicist Carl Brown tackled that question. He and Guglielmo Marconi were working on a machine to send electromagnetic waves, radio waves, through the air. But they needed a way to see and study the results of their work. The answer was a glass bottle of sorts with a phosphorescent coating in the bottom. Shooting a stream of electrons into the neck and focusing them on the phosphor coating made the particles glow. He also knew that the stream of electrons generated from the cathode had a negative charge. Therefore, he reasoned, he could control the electron ray by using charged plates on the sides of the tube. Because opposite charges attract and like charges repel, the electron beam would bend away from a negative plate toward a more positive plate. Changing the charge on the plates changed the position of the beam. And they had the tool they needed. It was first called, understandably, the Brown tube. We know it as a cathode ray tube, or CRT. In a test instrument, the beam is used to trace waveforms or oscillations over time. We therefore call these instruments oscilloscopes. In 1947, Tektronix introduced its first Model 511 oscilloscope. It was very advanced for its day. Not only was it technically superior, but it cost less than 1/3 the price of its nearest competitor. Today, Tektronix continues its worldwide reputation as the manufacturer of some of the finest test instruments ever built. But our products are no longer limited to oscilloscopes. We now make over 1,500 products, options, and accessories. Products Carl Brown could never have imagined. Products found in space programs, in medicine, in television, in manufacturing, in research, in computer technology, in education, and in thousands upon thousands of other applications where accuracy, ruggedness, and versatility are key ingredients. The 7000 series and its cost-conscious cousins, the 5000 series, are good examples. These laboratory quality instruments incorporate several tech innovations. A baked ceramic CRT instead of the fragile glass tubes. Storage CRTs that will hold a single fleeting waveform for extended study until erased, another tech development. And yet another, the choice of dozens of plug-in modules to give the scope unheard of flexibility. And the ability to record incredibly minute events lasting perhaps only 1/1000th of a second. Need more capability? Tech Systems can design and build just what any customer might need for his own operation. Perhaps the need is for something totable. Choose from 24 models. weighing as little as 3½ pounds. A go-anywhere attitude without sacrificing accuracy. Here's one with a single purpose, locating trouble spots in wires. Why use a sophisticated electronic device to find a simple wire break? Well, say that it's in a telephone wire and the break is somewhere within 10 miles but 12 feet underground. Where do you dig? The Tektronix 1503 TDR will spot the break within 3 feet. Or perhaps the fault is in a wire somewhere between the nose and tail of this complex jet airliner. The 1502 TDR can find it within about ½ an inch in a 2,000-foot wire. On the other hand, Tex 400 series portable patient monitors are not designed to locate faults in the plumbing system, merely to monitor its operation and give a shout when something goes wrong. An instrument dedicated to its life-saving task. Special or single-function oscilloscopes can be found in many of Tech's product lines. For example, spectrum analyzers. In complex signals, such as from distant galaxies, or in two-way radio systems, or even in home stereos, spectrum analyzers break the signals down into identifiable pieces. What frequencies are present? How much distortion? What noise is in the signal? The spectrum analyzer shows all, quickly, accurately, and often at great dollar savings over traditional methods. Here's another one, Tektronix curve tracers. These instruments graph the actual operating characteristics of semiconductor devices, such as transistors, to make sure they're operating as they were designed to do. And logic analyzers, which show what's going on in the very core of computers, large or small, essential to both design and troubleshooting. Here's a pair of oscilloscopes that help broadcast engineers transmit the highest quality picture to your home receiver. See what happens when the brightness levels go wrong? Or when the colors go out of whack? Tech television products are used in television stations worldwide to help engineers monitor and regulate broadcasts, to ensure that the very best picture is sent to your home receiver. But we also build instruments to make pictures of a different sort, pictures we call computer graphics. Computers help us do countless things, from balancing our checkbook to exploring our universe.
Dear men from the planet Earth, first set foot upon the moon, July 1969, AD.
Before computers, some say neither was possible. Tech makes some of the most advanced and useful computer terminals in the business. For graphics, for color displays, for interactive educational systems, and a host of other applications. But we don't stop there. We also have graphic tablets for converting graphics into digital electrical signals, signals a computer can understand. Hard copy units for converting computer representations back into pictures again. Line printers, plotters, and modems that allow coded computer signals to be sent over telephone lines. The microprocessor has created a revolution in the abilities of many tech products. Microprocessors which make terminals more than terminals and give them capabilities not possible just a few years ago. Our 4051 graphics system, a microprocessor-based standalone system which can do complex tasks all by itself or with its peripherals. Of course, it can be used as a graphic computer terminal, too. Then there's the 4081 graphic computing system, useful in land use planning, electronic circuit design, architecture and landscaping, creative graphics for the textile industry, and literally thousands of other applications where complex graphics play a key role. The 4081 system is one of our more advanced information display products. Look for others in the future. Speaking of the future, we're already working on it, not only in computer hardware and software, such as these microprocessor development laboratories, but also in more everyday applications, many of which don't use CRTs at all. The functional design of TEC's TM500 series takes advantage of our modular approach. With the same basic mainframe, customers can design their own test equipment, choosing from the large selection of TEC plug-ins. Simple, compact, and versatile are terms which apply just as well to our digital service instrument, dedicated to digital troubleshooting applications. 22 different functions with the turn of a single knob, test and measurement functions which used to require many pieces of cumbersome gear, now in one very portable unit. Here's another TEC product with no CRT. Answer. It's the world's first fully automated digital system for measuring critical TV signal levels. It automatically monitors 36 broadcast functions and, with the aid of a Tektronix terminal and hard copy unit, prints out a permanent record of station performance. Permanent records are also important in other applications, such as research. For example, you might wish to record oscilloscope waveforms for future study. Our series of high-quality scope-mount cameras provide the solution. Sometimes, simple problems can be just as important to solve as the complex ones. How to move a lab scope from place to place is a problem for many of our customers. This is not the way unless surgery is in your short-term plan. Let's try it again. This time with one of TEC's Scope-Mobile oscilloscope carts. A simple solution to a painful problem. Here are a few more simple solutions. Calibration fixtures, terminators, attenuators, normalizers, adapters, cables, probes. Probes. Our unsung heroes, really. Probes don't flash or buzz or whistle, but are one of the greatest sources of potential error in sophisticated electronic measurement. We have designed dozens of probes, all toward eliminating that error, even at extremely high or low voltages, frequencies, or currents. Yes, we make over 1,500 products and options. You've seen many of them in this program. But we do more than just assemble them from store-bought parts. We create many of the thousands of components that go into our instruments. Switches, resistors, diodes, capacitors, transformers, even knobs and cabinets. We build our own when they're just not available in the marketplace, or when what is available just isn't good enough. You see, we think our customers are special, that they deserve the very best. And there are times when no less than the best is acceptable.